Hi friends, I welcome you all to the last class of this course, Technologies for Clean and Renewable Energy Production. Now, we will have a tutorial session which is based on the last 4 classes, and in this class we will solve some numerical problems. And our first problem, the statement is the bio-oil extracted from an oil seed sample has 90% triglycerides containing 3 long chains which can produce methyl esters of lauric acid, myristic acid and palmitic acid in equal molar ratio during trans-esterification using methanol and NaOH catalyst. Calculate the amount of biodiesel produced by the trans-esterification of 10 kg of bio-oil. Assume efficiency of the conversion is 70% and 10% of palmitic acid is converted to soap. How much glycerol will be produced and how much soap will be produced? How can we improve the efficiency of the trans-esterification? So, this is the problem statement. We are asked to calculate the how much glycerol will be produced and how much soap will be produced and how the efficiency can be improved. And it is given that after the trans-esterification, the methyl esters of lauric acid, myristic acid and palmitic acid are produced, and it is also given that 90% triglycerides are converted to biodiesel or the methyl esters of these 3 acids in equal mole. So, this is given. So, at first we have to get what is the molecular formula of the triglyceride, and as it is given that methyl esters of these 3 acids lauric, myristic and palmitic acid has formed. So, the produced methyl esters are given here. So, CH3, CH210, COOH, this OH will be replaced by CH3O. So, CH3, CH210, CO, OCH3. Then for this acid C2, this is equal to we are getting C11, H23, COO, CH3. For the second myristic acid, our methyl ester is CH3, CH2, 12, COOCH3, that is equal to C13, H27, COOCH3. Similarly, for palmitic acid, the methyl esters which will be produced, that is equal to CH3, CH2, 14, COOCH3, that is C15, H31, COOCH3. Now, what is the formula of the triglyceride or the oil? That is the one is your glycerol, CH2OH, 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 then H is replaced by this. So, C11H23 COO and CH3OH will be there and CH2 will be there. That means initially we have CH2OH, CHOH and CH2OH. This will form and this will react with CH3O and it is giving us C11 CH23 COOCH3. OCH3 is coming from the methanol which is used in case of the reaction which we have discussed in previous chapter. So, this is the formula of the oil or triglyceride we can get, and these are 3 methyl esters which are produced during the process. So, this is the scheme. A triglyceride reacts with methanol in presence of NaOH and then it gives glycerol plus 3 methyl esters of 3 different acids. So, now the molecular weight of the triglyceride which is given here, that is equal to 12 into 45 plus 45 C, then 86 A hydrogen. So, 1 into 86 plus 6 oxygen. So, 16 into 6. So, we are getting 722 gram. This is the molecular weight of triglyceride. Then molecular weight of glycerol, this is, so that is equal to 92. So, 3 carbon into 12, 8 hydrogen into 1 plus 3 oxygen into 16. So, it is becoming 92 gram. Similarly, we can get the molecular weight of this triglyceride, this methyl esters of lauric acid, and this is myristic acid and methyl ester of palmitic acid. Then the molecular weight we are getting 12 into 13, here 15, 13, 11. So, here 12 into 13. So, 13 carbon into 12 plus 23 plus 3 26 hydrogen into 1 plus 2 into 16 2 oxygen into 16. So, 214 gram, and here we are getting 12 into 15. So, 15 carbon into 12 plus 30 hydrogen into 1 plus 2 oxygen into 16. So, 242 gram, and similarly for this acid, this methyl esters, that is palmitic acid methyl esters. So, 12 into 17 plus 1 into 34 plus 16 into 2. So, 270 gram. So, these are the molecular weight of these methyl esters of different fatty acids. So, now our basis is 10 kg of bio-oil, and then triglyceride is 90%. So, 0.99 kg. So, moles of triglycerides in the oil is 9 divided by, we have molecular weight is equal to 722 gram. So, 0.722 we have to divide that mole. So, that is 12.465 mole is available in 9 kg, because 1 kilomole is equal to this 0.722 kg. So, moles of triglyceride converted into glycerin, that 70% is converted. So, it is given 70% is converted. So, we have to multiply it by 0.7. So, 8.7258 moles we are getting. So, glycerol produced will be this much moles multiplied by the molecular weight of glycerin, that is equal to 92 gram. So, 0.092 kg. So, 0.803 kg. So, this much of glycerin is produced. The first part is determined. Now, mass of produced C11H23COCH3 is equal to how much? Then we have the reaction, 1 mole glycerol produces 1 mole of each of these methyl esters of the fatty acids. So, how many moles we are getting here? 8.7258. So, that will also be same number of moles will be produced for this, moles of these methyl esters of these acids will also form. So, this into the molecular weight of this 214 gram. So, 0.214, that is equal to 1.867 kg. Similarly, for this case, this into this equal to 2.112 kg, and for this case this into this is equal to palmitic acid, methyl esters of palmitic acid, not 100% converted into these esters, some salt is also formed, that is 10%. So, 90% of this one. So, 0.9 will be there. So, this 2.120 kg is for methyl ester formation, remaining 10% will be for soap formation. So, mass of biodiesel will be how much then? This plus this plus this. So, this plus this plus this 6.099 kg. Then reaction for soap formation, we have, this is the ester that will react with NOH, excess NOH, and it is give the sodium salt of these fatty acids and CH3OH. So, this sodium salt of these fatty acids molecular weight 278, whereas this we are 270 gram. So, molecular weight of soap we can determine the 278. So, what will be the soap produced? Soap produced will be 278 divided by 270, 278 divided by 270 into how much of this ester is formed. So, that is 0.2356. So, that is equal to 0.2426 kg. So, now we are able to determine how much soap will form, how much biodiesel will form, and how much glycerol will form after the transesterifications of this oil. So, how we can improve the efficiency? We can use the heterogeneous catalyst. Here we have used the homogeneous catalyst. So, soap formation is there, but if we use heterogeneous catalyst, soap formation will not be there, and we will get the improved performance of the process. And then next, problem number 2, in a high rate biogas plant, food waste is anaerobically digested to produce biogas. The slurry contains 8% of solid food grains. The elemental composition of the food grains on dry basis is carbon 58%, hydrogen 8%, oxygen 26%, nitrogen 8% on mass basis. Around 80% of the food grains are converted to biogas, and all the converted hydrogen forms methane. if the flow rate of the slurry is 4500 liter per day, calculate the rate of biogas CO2 plus CH4 production. This is the problem statement. We have to calculate the biogas productions, that is CO2 and CH4, and the slurry we are using is given 4500 liter per day, and how much solids, organic solid is available, that is also 8% food grains, and composition is also given, carbon, hydrogen, oxygen, nitrogen. So, by simple mass balance we can solve the problem. So, what is our basis? Flow rate of the slurry is 4500 liter, it is given. If we assume the density as 1, so then the 4500 kg will be the mass of this slurry. So, 8% is solid. So, 0.08 into 4500, that is 360 kg is our organic load in it, so organic solids on it. Then the carbon percent, hydrogen, oxygen, nitrogen is given. So, how many carbon gram or kg of carbon is present, that we can get, that is carbon present in 360 kg dry food grains equal to 360 into 0.58. So, that is equal to 208.8 kg. So, hydrogen is 360 into 0.08, that is equal to 28.8 kg, and oxygen is 360 into 0.26, that is 26%. So, 93.6 kg. Similarly, for nitrogen 360 into 0.08, so 28.8 kg. So, these are the different elements present in this organic food. Now, it is given that 80% of food grains are converted to biogas. So, 80% of these components will also be converted to different oxide forms, and so carbon will be converted to biogas, that is 0.8 into 208.8 equal to 167.04 kg. Hydrogen will be converted 80% of total, that is 23.04. Since all the hydrogen is converted to CH4, it is given the hydrogen is completely converted to CH4. So, methane produced will be how much? So, CH4 C plus H CH4 it is giving. So, 2H2 1 mole it is giving, 1 carbon reacts with 2 H2 and gives CH4. So, this is your 12 plus 2 into 2 and this is equal to 16. So, this 16 from 4 gram of we are getting 16 gram methane, 4 gram of hydrogen we are getting 16 gram. So, now we are using this hydrogen 23.40 kg. So, this into 16 divided by 4, that will be the methane production. So, that is equal to 92.16 kg or 5.76 kilomole. Now, carbon used for methane production. So, carbon converted is your this much, and then this much kg carbon used for methane production. So, for this reaction, so carbon plus O to CO2, this reaction will also take place. So, rest of the carbon may be used for this. So, total is your 167.04 and minus this, that is equal to 97.92 kg is used for this reaction C plus O2 equal to CO2. And what will be the CO2 produced? CO2 produced will be this much carbon 44 and this is 12. So, 44 divided by 12 into 97.92. So, it is giving 359.04 kg, that is equal to 8.16 kg mole kilomole. So, CH4 plus CO2 equal to how much now? Now, we are getting 97.16 kg, this is methane produced plus CO2 produced. So, CO2 produced 359.04 kg. So, total 451.2 kg of biogas is produced. Now, problem number 3, in the above plant the effluent from the digester is used for the production of manure through composting. If 75% of the organic compounds present in the effluent are converted to manure, what is the rate of manure production? So, what is the sludge we are getting that is converted to manure? 75% organic compounds present in the effluent. So, organic compounds present in the effluent is equal to how much? 80% is converted to biogas. So, rest 20% will be available. So, 360 into 0.2, that is 72 kg. Out of this 75% is converted to manure. So, what will be this? 72 into 0.75. So, 54 kg per day manure will be produced. Then problem 4, a 60 HP energy efficient motor is operating at 70% load. At this load, efficiency of the motor is 87%, and the power factor is 0.83. A standard motor with same load shows an efficiency of 80% and power factor of 0.8. If the price of 1 unit of electricity is rupees 3.10, calculate the annual saving in expenditure for energy. Assume 20-hour consumption per day for 300 days in a year. Assume VA demand charge as rupees 175 per kVA per month. So, similar type of problems we have discussed in energy conservation chapters, where we have calculated the time required to recover the amount and payback period, but now we have to calculate only the annual saving in expenditure. So, rating of the energy efficient motor, rating of the energy efficient AC motor is 16 to 0.75, this 75 because the conversion of HP to watt. So, that is in kilowatt, 750 watt equal to 1 horsepower we are assuming. So, 16 to 0.75 45 kilowatt. So, input power to motor 45 into 0.75 by 0.87, this is energy efficient motor. So, we are getting 38.79 kilowatt, and kVA demand 38.79 divided by 0.83 because the power factor is 0.83 as it is given here. So, this value is coming 46.73 kilo kVA kilovolt ampere. So, kVA charges per year is equal to this much into 175 into 12, that is 98,133, and energy charge equal to 38.79 into 3.10 into 20 into 300. So, that is equal to rupees 7,21,494. So, energy demand plus energy cost we are getting this plus this one equal to 8,19,627 rupees, and rating of standard AC motor is 16.75, again that is equal to 45 kilowatt, and then power input divided by 0.8. So, 42.19 kilowatt. So, kVA demand is 42.19 divided by 0.8, 52.73 kVA. So, kVA charge this into 175 into 12 rupees 1,10,742, and energy charge per year is equal to this 142.19 into 3.10 into 20 into 300. So, 7,84,734 rupees. So, total 8,95,473. So, here we are getting the annual saving is 8,95,476 minus 8,19,627. So, rupees 75,849. So, up to this in this class, and I hope you will enjoy the course, and best of luck to those who will take part in the examination. Thank you very much for selecting this course and for your patience.